Uh, Welcome to videos on linear integrated circuits. In this video, we shall see an application of triple five timer, which is nothing but a voltage controlled oscillator. So we know that triple five timer can be used as a stable multi-operator using two resistors RA, RB, and a timing capacitor C. So we have seen in the previous videos that we can adjust the on time and off time by changing the values of RA and RB. We also obtained the relationship between the on and off time with respect to the circuit components, and it was found out that high time, that is on time, is given by 0.69 C into the resistance RA plus RB. Similarly, the off time, that is TL, is given by 0.69 C into RB. Of course, we know that. So we have an extra pin in a triple pack timer that this threshold voltage, that is VTH, can be controlled at number 5. So we know that in the previous example, so the on time is decided by the time up to which the capacitor takes to reach up to VTH. Using control voltage, we can certainly change the value of VTH. We also know that VTL and VTH are interrelated. If you change VTH, VTL will certainly change, because VTL is always half of VTH. So by using external voltage, we can change the value of VTH, which will certainly change the value of VTL. Meaning to say, so by using an external voltage, we can change VTH, which will change the on time of the transistor, that is the time required for the transistor, the capacitor to go to VTH, that is threshold voltage. I can see this is the expression. How do we find the expression for the on time of a stable multioperator with an external voltage at pin number 5, that is control voltage. Now VTH is not 2/3 VCC, now it is connected to an external voltage, that is V external. So we know that VTL is half of VTH, which happens to be, since VTH is V external, so VTL is now half of the external voltage. So we know the capacitor voltage given by this equation, that is V final minus V initial into e power minus T by RC, where R is the timing resistance and C is the timing capacitor. In this case of a stable multioperator, capacitor charges through RA and RB, so that's why this R is replaced by RA and RB. This capacitor is same C. The initial voltage is half of external voltage. So we know that initial voltage of the capacitor will be VTL, which is half of V external. The final voltage is VCC. But at T is equal to TH, we know that the capacitor voltage will reach the VTH, which is nothing but V external. So by substituting all these values into equation 1, we end up with getting an expression for T on as RA plus RB into C, ln of this VCC minus half external by VCC minus V external. So as we can see here, so we can actually change the on time of this triple five timer by changing this external voltage. So that's why this is called as an voltage controlled oscillator. If the on time changes, we know that the overall time changes. So that's why the name VCO, that is voltage controlled oscillator. So this is the expression for the on time. Let us also have a look at what is the expression for the off time. So again, we have the same expression of VC, and we know that what is the initial voltage of the capacitor while finding the off time. So while finding off time, we know that initial voltage will be the V external, and the final voltage will be 0 volt. Why this is so means, so if we just look at the graph here, so this is what is TL. So when you're finding TL, the initial voltage is VTH, the final voltage happens to be 0. At T is equal to TL, the voltage of the capacitor is VTL. So in this case, VTH is V external and VTL is half of V external. So that's why the expression for TL, that is the off time, we are substituting the initial voltage as V external, the final voltage as 0, and the capacitor voltage at which T is equal to TL is half of external. So by substituting all these values to this equation 1, we end up with the expression for T off is nothing but TL is given by 0.69 RB into C. It is interesting to see here that the off time of the stable multivibrator with V external is 0.69 RB into C, whereas the on time is related to V external. It is surprising that there is no V external term here, meaning whether we connect the external voltage or if we don't connect the external voltage, the off time of the stable multivibrator remains the same. That means, so this is the expression for TH and TL. So without using any external voltage, you can see TL is given by 0.69 C into RB, which is the same in the case where you are having a external voltage connected to the number 5, that is control voltage. So here, so in case of a stable multivibrator using V external, only the T on changes with respect to the external voltage, whereas T off remains constant. So certainly the value of total time changes, which will change the frequency. So that's why if you are using an external voltage, we can call a stable multivibrator as a voltage controlled oscillator. Now these are the expressions for T on and the T off for a VCO. So we are assuming some value of RA and RB in the value of C, and of course the VCC and V external. We are finding out what is the on time using the expression corresponding to on time, and the off time is being evaluated here. And of course we have done it for different values of RA, RB and different external voltages. As you can see, as the external voltage increases, the T on will be slightly more compared to the T on without the external voltage. So we shall do some simulation using this external voltage and try to convince ourselves that the V external will going to have a modification on T on time. So there will be no change in the T off time with or without the V external. We shall do some simulations. Okay, we have rigged up a 12-5 timer in a stable mode using an external voltage connected to this CV, which happens to be the control voltage. So let us simulate this and try to see what is the on time off time. So here we have this is a free running oscillator. Now you can also see how does the capacitor is charging, discharging. Now the capacitor charges up to V external and half of V external. So you can just have a look at what is the capacitor voltages. It is VTH is 4 volts and the VTL is 2 volts. It is not 1/3, 2/3 of VCC. It's actually, now we can see this is 2 volt. This is VTL. Of course, the other cursor I'll put it on the VTH. VTH happens to be 4 volt. So just have a look at, now this is 3.97, which is 4. Here it is 2 volt. So capacitor will be charging up to VTH and VTL. VTH is now decided by this external voltage. You can also have a look at what is the time period here. You can see now the time period of, now we are just trying to find the time difference between these two, which is the off time, which is now 69 microsecond. You can also verify that with the design. So we are having it for this. Let me just verify what is the on time off time. So this is the design what we have connected here. It is 1 kilo ohms RA RB, C is 0.1 and VCC is 5 and the external is 4 volt. The T off is 69 microsecond, so that's what we obtained there. Let us also verify what is the on time here. So theoretically it is 219. So let us verify whether it is 219 or not. So let us just go back to simulation and try to see what is the on time. So let me verify the on time here. So let me just move this to this reference. Now you can see it is 220. So we are supposed to get 219. So we're getting very close to that. So the off time is 69 microsecond. The on time is 220 microsecond. So let us verify if I change this external voltage from 4 volts to 3 volts. Let me make it this 3 volts. So as per the equations, the off time should not change. Certainly the on time will change. So let me just find out what is the off time now. So I have made this equal to 3. So let me run this. If I run this and try to see, now you can see the on time is reduced. So let me just see what is the off time. So I'm just trying to find out the off time. It is from VTH to VTL. So this should be again 69 microseconds. So you can see it is exactly 69. Of course, it is 70.25, which is almost very close to 69. So meaning that the off time of the stable multivibrator even with VCO remains constant. It is not depending on the V external, only the on time changes. When the V external was 4 volt, the on time was 219. Now I can see the on time is 111 microseconds. In this way, we can realize a voltage controlled oscillator by connecting an external voltage to this pin number 5, which is the control voltage. Of course, we have to ensure that the control voltage never exceeds 5 volt. So we can find what is the reason for that. So 5 volt, this control voltage should never be greater than the VCC here. We can apply VCC as 12 volt. We can apply the external voltage up to 12 volt. So the minimum voltage, there is no limit, but the maximum voltage should never be exceeding the supply voltage. So in the next video, we shall see how do we get a pulse width modulation from a 555 timer.